Oh, right. So, guys, I was requested from the Google form to do another kind of extended video on explaining horizontal asymptotes and just the graphing in general. You guys hear a loud banging in the video. That is at my house. They're doing some work, so that's what's going on. So if you hear loud like knocking, they're working on the backsplash in the kitchen. So that's what's going on, and that's why there's that loud banging. Hopefully you can hear me over it. I'll try to speak a little louder and really project so you can hear me. So yeah, just want to let you know what that noise is. So I'm going to call this the bonus video. You don't have to watch this, it's not required. But this is kind of like a review for the quiz. I'm not going to go over x and y intercepts. I'm not going to go over vertical asymptotes. Seems like everyone's pretty clear on kind of how to do that. No one's really asked questions on it. The most, not I don't want to say complaints, the most questions I've seen are horizontal asymptotes, and then of course the graphing yesterday. People were a little confused. I'm just going to give you guys a picture of what the quiz is going to look like. There are going to be some individual questions where you're going to be just asked, what's the horizontal asymptote? What's the vertical asymptote or asymptotes? What is the x-intercept? What's the y-intercept? If there is none, I will have an answer that's none. So if I have an answer that's none, and you get no, you can see there's no x-intercepts, just click the word answer that says none. Then there will be, I think, I'm going to put I'm thinking between 2 or 3, so don't quote me on this, 2 or 3 graphs where it's just going to be graph this function, and of course you can't actually draw a graph for me. There's going to be 4 images of 4 different graphs. You have to pick which one is the graph of that function. I'm going to give 15 minutes for those. I'm going to give a little more time so you have the time to find all the stuff. I want to give you guys plenty of time. So you have 15 minutes to graph those, which I think will be enough. If you kind of know what you're doing and you study, you can kind of have an idea. But the other ones will still be 5 minutes. So they'll all be 5 except for the 3 graphs. You have time to graph them. They'll be 15. I would sketch the graph because in case you pick the wrong answer for something, you can always send me your picture and be like, hey, I picked the wrong answer, but here. All right? So that's kind of what the quiz is going to look like. It's probably going to be about, I don't know, no more than 15 questions, probably closer to 12, 10. And again, don't quote what you get from quizzes. I'm going to, I need to see what graph you picked, so on and so forth, I'm going to give kind of credit where credit's due, okay? And I know it's a little harder with that. Anyway, so I'm going to do 3 more graphs, one of each. So I'm going to do 3 more graphs, and that'll kind of give you guys a feel for what we're going to do. I thought about doing 4 graphs. I'm going to try and keep this video still to a decent length, so I'm going to do 3 more graphs, one of each. All right. And I'm going to kind of I'm just going to tell you what the intercepts are and the vertical asymptote is. Then I'll go through in depth the horizontal asymptote and the graphing. Okay. All right. So I'm going to kind of walk over to the camera. So I have my notes right here on my laptop over here. All right. So the first function we're going to look at, we're going to graph and find the horizontal asymptotes in depth are the graph. All right. It's going to be f of x equals 6 minus 2x over 1 minus x. And I'm in front, I always move out of the way. Okay. So if I were to find my x and y intercepts, if I want to just kind of start sketching my graph. All right. I'm just going to tell you those because I'm trying to. So I never got complaints on those. So the x and y intercepts. Because remember, those are coordinates. We practiced finding them yesterday. This graph will have the y-intercept 0, 6, and the x-intercept 3, 0. So I'll do that when I find those. I'll just plot them. All right. So I got 3, 0. So 1, 2, 3 to 0. And then 0 to 6. So 0, 1, 2, 3, 4, 5, 6. So 3 to 0, 0 to 6. Graph my y and x intercepts. Alright, not too bad. Then I don't have to go and find my vertical asymptote. In this case, in this problem, I would have one vertical asymptote, and that would just be the line. So my vertical, vert asymptote would be the line x equals 1. So remember that's going to be, we drew it yesterday. We're going to use that teal color again. It's going to be a dotted line on x equals 1. Alright, so I'm just going to draw it. That's 2, sorry about that. X equals 1. So vertical asymptote. Alright, so I got my vertical asymptote. I got my two intercepts right there and there. Alright, so now I have to find my horizontal asymptote. Okay, so where people get really, really confused. At least from all the stuff from all the questions I've gotten. Okay. So, how do you figure out what this n and m are? Okay, n is going to come from the top. Hopefully you guys have gotten that. So n is going to come from here. This is not the negative n. It's just I'm just doing like a little dash. N is going to come from here. M is going to come from here. N on the top is going to be the highest power of whatever variable it is. In this case, we've mostly seen x. The highest power of x at the top of the fraction if there is one. If there was no x up here, or if there was no x down here, no x to any power, either of these would just be 0. So again, if there's no variable at the top or bottom, your n or m is just 0. Alright? But, okay, in this case, I have a 2x up here, right? So this x is an x to the first. If I look at this whole expression at the top, x to the first is the highest power of x I have at the top. So n, in this case, is the highest power of x is 1. Okay, at the bottom, I look at the same thing. I have 1 minus x, x to the first. X to the first is the highest power of x I have at the bottom. Since that's the highest power of x, x to the first, m is also 1. Okay, well, what do we see here? N and m are equal. Since n and m are equal, the horizontal asymptote, it's a y equals line. And the way I'm going to find it is, since they're equal, I'm going to use the numbers that are in front of the highest power of x. Since they're equal. It's only because they're equal. Since they're equal, so my horizontal asymptote would be y equals -2, the number in front of that x to the first. And this is technically a -1 in front of this one. So you divide them, and you would get +1. Or no, +2, excuse me. -2 divided by -1 is +2. So my horizontal asymptote would be at y equals 2. Alright? So hopefully, again, I'm really, really trying. So again, highest power of x at the top is whatever n is. Highest power of x at the bottom is whatever m is. If they're equal to each other, you just divide the numbers that are in front of the highest power of x, whatever it is. If, then we'll get into, again, if n is less than m, it's the x-axis, excuse me. It's y equals 0, which is the x-axis. Or, if n is greater than m, then there is no horizontal asymptote. So not every graph is going to have a horizontal asymptote. It just depends on the problem. Okay? So our horizontal asymptote here is y equals 2. So what I'm going to do is, I'm going to draw my horizontal asymptote. It's going to be a dotted line at y equals 2. It's going to be like this. Y equals 2 is right here. So that's the line, y equals 2. Alright, so now we sketch our graph. So in this case, we have it pretty easy. So what we want is we want 1 point. Okay, so someone asked me about how do you find the coordinates? How do you figure out what coordinates I'm going to use? I really, in this case, when I just have one vertical asymptote and then a horizontal asymptote, I want to find 1 point to the left of the vertical asymptote, so 1 point on this side, and 1 point to the right of the vertical asymptote on this side. Well, in this case, I already have 1 point to the left. That's going to be my y-intercept 0, 6. This is to the left, see, it's to the left of my vertical asymptote. If I didn't have that point, I would just pick maybe my first whole number to the left of my asymptote and do it that way. Since I already have 1 point to the left of my vertical asymptote, following that teal line, I'm going to draw my first curve. So what I'm going to do is, I'm going to sketch this. It doesn't be perfect. I'm going to draw, it's going to get really close. It's going to get really, really close to 1, but it's never going to touch 1. It's going to kind of go down and around like that. It's going to get really, so that's my best sketch. Again, I'll try to post better pictures of these. But it's going to get really close there, but it's never actually going to touch. All right? So that's I got 1 point to the left. I'm just going to kind of draw the curve. All you want to do is going to be a curve, kind of like this. And you want to try it, if you were sketching this for me, and you were actually doing this on the tests for me in person, you'd want to try and get as close to these dotted lines as possible, because then an asymptote means that it's going to get really close to those values, but it's never going to touch, it's never actually going to hit those values. All right? So then, my other point here, this is to the right. I already have one point to the right of my vertical asymptote also, 3, 0. This graph was actually pretty easy. So since I already have a point to the right, all I have to do is draw this curve. So my curve's going to kind of start up here. It's going to start really close to here, and then it's going to kind of go down and get really, really close to that teal line, but it's never actually going to hit it. So again, you're asking about the coordinates. You want to find one, if you have one vertical asymptote, and then let's say a horizontal asymptote, maybe you don't have one. You want to find one point that's on the left. So in this case, you already had a point to the left, and one point's on the right. It can be any point to the left or right. And then when you draw your curves, you want to get them really, really, really close to those dotted lines, but never actually touching them, because they never are going to hit that value. They're going to get really, really close to that value, okay? So that's my first graph. Hopefully I'm answering questions as we go along here. Again, one point to the left, one point to the right. That's if I have one, I repeat, one vertical asymptote, okay? Now we're going to do two more, where I'm going to have two vertical asymptotes, kind of like the other two I did yesterday. All right? Again, horizontal asymptote. N is the highest power of x on the top. M is the highest power of x on the bottom. If there is no x on the top or bottom, or there isn't x on the top, just on the top or just on the bottom, that means either n or m is 0. N is always on the top, m is always on the bottom. If they're equal to each other, like they are here, you just divide the numbers that are in front of the highest power of x. If n is greater, there is no horizontal asymptote, which maybe is what you want. And then if m is greater, the bottom is greater, then your horizontal asymptote is the x-axis, or y equals 0. Okay? So again, hopefully, trying to repeat stuff, hopefully it's making a little more sense. That's my first graph. So that one was pretty easy because we already had those coordinates. If I didn't already have one to the left and one to the right, I actually need to find those coordinates. Okay? Sometimes you won't always need to find them. It just depends on the problem. In this case, it's almost kind of set up for us pretty easily. All right, so let's do a second one. And I apologize if the banging is taking over my voice. I'm trying to talk loudly and project so that you guys can hear me. All right. So let's look at a second function again. All right. So I'm going to have a second function here. Just pull up my notes. Okay, it's going to be 8 over x squared plus x minus 6, all right? So, if I were to find my x and y intercepts, there's going to be a y-intercept at 0 and negative 4/3. Just want to get that in decimal form. It's always easier to graph a decimal. So that's going to be about negative 1.3, okay? All right, so that's my first thing. Then, I'm going to have no x-intercept. So this is my y-intercept, if I were to find it. My x-intercepts, I'd have none. So again, if you were answering this on a quiz, unless I gave you this function, I just said find the x-intercepts, you would just pick the answer none. Alright? So then, what I would do is, now I find my vertical asymptotes, I would actually have two here. So my vertical asymptotes, again, I'm not going over the whole thing, I'm just going over the horizontal and the graphing, that's what I got the most questions on. My vertical asymptotes would be x equals negative 3. Okay, and x equals 2. Alright, so let's kind of graph what we have so far. So, let me draw my graph. So we have a point, 0, negative 1.3, so 0 to, I'll just use the pink again. 0 to negative 1.3, it's going to be here's negative 1, here's negative 2. Now I got to get out of the way, I'm just kind of trying to write. So 0, negative 1.3, there's my y-intercept right here. Then I've got two vertical asymptotes, I'm going to draw them in teal again. I have one at negative 3, so negative 1, negative 2, negative 3. I'm going to draw a little dotted line here. And then one here at 2. So I'm going to go 1, 2, and draw them this way. Alright. So, there's my two vertical asymptotes. Alright, so now I gotta find my horizontal asymptote. So again, I look for my n and my m. Okay. Again, n is at the top, m is at the bottom. N is the highest power of x at the top, m is the highest power of x at the bottom. So in this case, if I look at the top, there's just an 8 up there. There's no x. Okay, there's nothing with x in it. Since there's no x's at the top, literally nothing, my n is just 0. Same thing with the bottom. If there was no x's, the m would be just 0. Since there's no power of x, it's just 0. At the bottom is m. So m here, okay, the highest power of x there, I have an x and an x squared. Well, the higher power of x between those is x squared. So m is that highest power, so that's 2. Okay, well, that means that n is less than m. If you look back, all the way back to the original notes, where it says n is less than m, it means that your horizontal asymptote, alright, sorry, is just going to be, so if n is less than m, so the top is less than the bottom, then what happens is your horizontal asymptote is just y equals 0, or what I refer to in also the homework answers as the x-axis. This x-axis, this is the line y equals 0, because of course this is y equals 1, 2, 3 as you keep going up. So your x-axis is your, as we call it, your horizontal asymptote. So your curves are never actually going to get to, that's why there is no x-intercepts, because so we're going to touch that. Alright, so now, in this case, in this problem, we have 3 sections we got to do. We got to do this section, the middle section, and the end section. In my opinion, what I would do first is I would do the 2 end sections first, okay? That would be my thing. So the first thing I would do, okay, now this is -3, right? So what I would do is, I would go 1 over, and I would just plug in -4. So again, what I'm doing is I'm doing 1 to the left of this first vertical asymptote. So I'm doing 1 to the left here. That's how I'm picking that point. Okay. So I'm actually going to erase this so I have more room to kind of show you guys what I'm doing. All right. So what I'm doing is I am picking 1 point to the left of this vertical asymptote. Okay, so I'm using this first vertical asymptote. I'm starting 1 to the left here. So I'm going to plug in -4. Okay, I'm plugging in -4. Alright, so I'm going to do f of -4. So all I'm doing with that -4 is I'm plugging it into the function. Okay, I'm getting this point because I'm doing 1 to the left of this vertical asymptote here, excuse me. So if I plug in -4, I'm going to get the answer of 4/3. I would also call that 1.3. So if I do, so this is going to be the point, -4 is the x, and then, or this is 1.3 repeating, there's going to be 1.3, right? So I'm going to do at -4, I'm going to actually plot this point, -4 here, if this is 1, 2, 1.3 is going to be a little bit above 1 here. So I plot that point. Then what I'm going to do, guys, is I'm then going to just graph this curve. So I'm going to go around like this, and again it's going to should get really close to that teal line, really close to the x-axis, but never actually touch it. Okay, so all I need is 1 point. So 1 point to the left of this first vertical asymptote. So we have 3, right? Now I'm not going to do the middle yet. Let's do the middle last. The next thing I want to do is I want to do 1 point. I'll just redraw this y-intercept. I want to do 1 point to the right, so I'm going to go 1 whole number over to the right of this vertical asymptote on this side. Okay? So in this case, this is 2, right? This is my vertical asymptote was at x equals 2. I'm going to plug in 3. I'm going to do that next. So now I'm going to plug in 3, 1 to the right. So I'm getting this point again. As I went 1 to the left of this one on this side, I'm going to go 1 to the right of this one on this side. Okay? So I'm going to do f of 3. If I plug in 3 to my function, that function I just plug it in everything where x is, okay, I would actually still get the answer 4/3, or 1.3 repeating. So I have my other point here is going to be 3 for x, 1.3 for y. So again, we're just sketching, we're just trying our best. So I go 3 to 1.3. I try to graph it around the same point I just plotted that one. And then I'm going to draw my curve again. It's going to go really, really close to there, really, really close to that line. That's how we're actually going to touch it. Okay, so those are my two first kind of curves. Okay, so those two are pretty easy. You find a point, one to the left of the one on this side, one to the right of the one on this side, and then I just kind of draw the curve, sketch it, and you get really, really close, really, really close. You want to get really close to these asymptotes, but they're never going to touch those values. All right, now you're like, this middle piece. This seems really confusing. What do I do with this middle piece? All right, so I have one point in the middle, the y-intercept here, which was, let me just double check, I think it was 0, negative 1.3. Now, these middle, like I showed you yesterday, I had a kind of a curve in the middle that went like this at one point, and then I have one that went like a big U, upside down U. So you have to figure out the behavior on either side of this y-intercept. There's always, usually when you have these graphs, there's going to be a y-intercept in the middle. Of course, it's going to be in the middle because of the y-axis. You want to figure out, is the middle curve going to look like something like this, or is it going to look like an upside down U? That's going to be a little bit tricky to do. With this graph, it's actually it's even a little more tricky. Because if you try to plug in 1 or negative 1, you're actually going to get the same value you got here. It's going to be negative 1.3. Okay, so that's not going to help you at all if you plug in 1 or negative 1. So my suggestion is, if you do that, just try the next number over. Just try to get as close to these values, like the asymptotes, as possible, okay? That'll really tell you your behavior. So if I want to get the closest, I mean closest I can here to, to negative 3, I'm going to go to negative 2.5. That's the closest, like, kind of normal number here. Negative 2, because this is negative 2, right? Negative 2.5 is the closest, like, normal number, rather than just, like, picking, like, negative 2.7. So I'm going to plug in negative 2.5, actually. That's the closest I can really get to negative 3 without, like, getting to some weird, like, negative 2.9, I guess. But it's the closest, like, normal, semi-normal number I can pick, right? So I'm going to do negative 2.5, okay? Again, why I picked that? It's about the closest I can get to negative 3 as possible, okay? Okay. Let's just take a step back for a second. I know I'm talking about a lot. I know it's a little overwhelming, guys. I got this. So again, someone asked me how I picked the coordinates. I really want to make sure I'm answering this perfectly. Hopefully horizontal asymptotes are making more sense. We're still going to do one more. How I picked these points was, so I drew my two vertical asymptotes. I got a horizontal asymptote here. What I did was, when I have two of them, right, I did one to the left of the one that's furthest to the left, right? I found 1 point, one whole number over to the left of negative 3. You could have picked negative 3.5 as well. I plotted the point, I plugged it into the function, right? Found the y part of the coordinate and graphed it. I plotted negative 4, 1.3, and I drew my curve as close to my asymptotes as possible, because it's going to get really close to them, but it's never going to touch them. All right, then I went one to the one that's furthest right, x equals 2. I picked one whole number to the right of that, which was 3, right? You could have picked 2.5 as well. I then plugged in 3 to my function, got 4/3. I then plotted that point, and then I drew my curve again, get really, really close to those asymptotes, but never actually touching them, because that's what an asymptote is. All right, now, in the middle here, I had a y-intercept that I plotted in the beginning, which was 0, negative 1.3, or negative 4/3. Now, I need to figure out what the behavior to the left and to the right of this y-intercept is, okay? So what I figured out is, what I'm doing is, first of all, I'm going to the left, right? I picked negative 2.5. Now you're saying that's really random. Well, I tried negative 1, I tried other points, and they kind of gave me something similar to negative 1.3. And I just kind of picked the number closest to my asymptote, but also be easier to graph, because I'll kind of see exact behavior. I want to see the behavior on either side of this y-intercept here to figure out, is my curve going to look something like this, or is it going to look like a big U, okay? Because you saw those two graphs yesterday. So that's what I'm doing so far. So now I'm plugging in negative 2.5, okay? If I plug that in, I'm going to plug it into my function. Maybe it's a little weird. I'm going to get a weird fraction, which is going to be negative 32 over 9, which is actually about negative 3.5. You can estimate that. So if you want to round it, it's approximately, negative 3.5 repeating, really. So Now what I'm going to do is I'm going to plot the point negative 2.5, negative 3.5. Okay, so again, what I'm doing with these points is I have that original function. I'm just plugging them in for x and then getting a value out, and that's going to be the y part of my coordinate. So I'm going to plot the point. So this is going to be negative 2.5 here. I'll draw them in blue. This is negative 2.5 here. Here's negative 2. Here's negative 3. I'm going to go down to 1, 2, 3, 4. It's going to be down to negative 3.5. Right? We just double check that. Negative 32 over 9. Yup. Is negative 3.5. So double check to make sure I get my decimals correct. It's going to be down a little bit. So it's going to be something like around here, right? So yeah, I'm just trying to sketch best I can. Alright. Then I'm going to do, now again, I'm picking, seems like weird numbers. Now I'm going to do, so if I pick the closest number to 2 without getting a 2, well, that would be 1.5, right? Closest normal number, because I would have like, here's, 0.5, 1, 1.5, 2, if I'm doing my halves, right? So now I'm going to plug in 1.5, because I told you guys if I tried 1, it's going to give me negative 1.3, which is not going to help me, because then it's, what's the behavior on either side? So again, if you try a point and it gives you the same number, just try the next half point over, all right? So let's try f of 1.5. So I did the point to the right, I have that down. Let's do the point to the left. So I do f of 1.5, I actually figure out I also get negative 3.5, or negative 32 over 9. So this point here is going to be 1.5, negative 3.5, repeating really, all right? So now I'm going to graph this point. So I have, here's negative 1, here's 1.5, sorry, positive 1.5. And then here's negative 3.5, so they're actually going to be right around the same point. Okay, well, what do we see here? On both sides, it looks like it's starting to kind of be that downward U. Now again, this won't be a perfect picture, I'm really just merely sketching this. But it's basically just going to be, it should be like, kind of like, get really close to there. It's going to kind of go down. It's going to kind of get really, really close. It's a weird looking, it's almost literally a U. That's literally what it looks like. I mean, the picture, I'll send this a little bit wider, but that's what kind of the middle part is going to look like. Because it's going to get really close to this value, it's going to get really, really close here, but it's never actually going to touch. So that is that middle point. Again, hopefully that makes more sense. So again, 1 to the left of the leftmost vertical asymptote, 1 to the right of the rightmost vertical asymptote, then 1 on the left and right of that y-intercept that you're going to have in that middle part of the graph. I would always do that last, or you can do it first. You just want to figure out the behavior. Is it going to, again, because there can be two kind of different curves that we've talked about, and I've kind of shown you guys. So that's that. Again, I picked negative 2.5 and 1.5 because I told you I tried other values, and at least though I tried 1 and negative 1, and it came out to be negative 1.5 again, or negative 1.3. It came out to be the same value here. So you need to make sure you're actually getting what's the behavior on either side. You're trying to see, does it, do a little like, or does it do a U? All right, so that's the second one. Again, hopefully this is helping. I really, really hope it is. All right, so let's do one more. So of course you had to guess the last one is probably one of those other curvy looking graphs. Just trying to do one more of each just so everyone kind of get even more examples. Again, hopefully horizontal asymptotes are making more sense. I hope you guys see I really am putting a strong effort in to help you guys understand this stuff. I really want you guys to get it. Alright, so last but not least, last problem of the bonus video. Alright, so let's look. Okay, so this function, this rational function, is going to be f of x equals 4x squared minus 36 over x squared minus 2x minus 8. Alright, so again, x and y intercepts we'd find first, vertical asymptotes. I'm just going to give them to you. So x intercepts, y intercepts. So I have x intercepts of negative 3 and negative 3, 0 and 3, 0. So don't get tricked on the quiz. I might just put one of these as an answer. Make sure you remember that, the square root solve. When you solve the square root, you get 2. So make sure you pick, if there's one that says both, pick the one that's both. Don't get tricked by picking one. It's not both. And And my y-intercept's going to be 0, 9 halves, which if I just find 9 halves as a decimal really quick, 9 halves is going to be 4.5. See, I would always make it a decimal just because for graphing purposes. So I got x-intercepts by y-intercepts. And then I have vertical asymptotes. I have 2 vertical asymptotes if I were to find them. Again, I'm not going over these because I didn't seem to have any questions on these from the Google form. I would have the lines x equals -2 and x equals 4. Alright, then before I plot anything, let's just find my horizontal asymptote. Let's go over that one more time. So again, I look at the top and bottom, right? Remember, the top is n, the bottom is m. Alright? So I look at the top equation and I see what is my highest power of x there? It's x to the second power. That means n is 2. I look at the bottom. What's my highest power of x there? X to the first and x squared. The higher power, of course, is x squared. So that means m is 2. Oh, look, they're equal. So my asymptote is going to be the line y equals, okay, well, okay, the highest power of x next to the 4, the number that's next to the highest power of x on the top is 4. Okay, so I'm going to use, it's going to be 4 over, and then the highest power of, the number next to the highest power of x on the bottom is 1. So it's going to be the line y equals 4, 1, which is y equals 4, of course. So again, if they're equal, you take the number in front of the highest power, that highest power of x, and you just divide them. That's only if they're equal. So I have a horizontal asymptote at y equals 4. Okay, so now, if we graph this out, alright, so let's kind of start drawing this graph. So let's graph out what we have so far. Again, sometimes the more points the better. Sometimes you have more points where you need them. I'm going to have to erase that side of the board in a second to finish this. So let's see, I have x-intercepts at -3, 0 and 3, 0. So let's draw those out. So 1, 2, 3, 1, 2, 3, 3, 0, -3, 0. And then I have a y-intercept at 0 to 4.5. So 1, 2, 3, 4, 5. There it is, 0, 4.5. Alright, then I have vertical asymptotes at x equals -2 and x equals 4. So here's x equals -2, right? And then here is x equals 4. Alright, so there's my 2 vertical asymptotes, alright? Then I also have a horizontal asymptote, so remember going this way at y equals 4. So let's draw that in. So I go up 1, 2, 3, 4, and I have a horizontal asymptote there. Alright, so I draw my horizontal asymptotes, my 2 vertical asymptotes, so on and so forth. Alright, so now, let's draw our graph here, guys. Okay, so again, first, I want 1 point to the left of the leftmost vertical asymptote. So my leftmost vertical asymptote is the line x equals -2 here. I already have 1 point on that side, which is my x-intercept -3, 0. I don't need to find the other points. All I need to do is just draw my curve there. So I'm going to kind of get really close to my horizontal asymptote, as close as I can, and just kind of like it's going to get really, really close there, something like that. Again, the reason I can already draw this curve is it's not perfect. The reason I can already draw this curve is because I already have 1 point to the left of my leftmost vertical asymptote. Alright? So again, my leftmost vertical asymptote, 1 point to the left. Alright. So next, I'm going to go to my rightmost vertical asymptote here at x equals 4. I want to go 1 point to the right there. Okay, well I don't have that point. I have no points over here yet. I'm going to go to the next whole number there. I'm going to go to 5. I'm going to find what happens if x equals 5. Okay? Now I'm going to kind of erase this here so we can kind of see how I find these points. Alright? So what I'm going to do is I'm going to plug 5 into that function I just had up there. And I'm going to see what happens. Alright, so I'm going to do f of 5. So basically that means I'm just plugging 5 in, okay? So if I do f of 5, I plug 5 in, I'm going to get the point 64 over 7. 64 over 7 is about 9.1, I want to estimate it. So I'm going to get the point 5, 9.1. So actually, so f of 5 is going to equal 9.1 if I plug it in approximately. It's like 64 over 7, which is approximately 9.1. So I'm going to get the point 5, 9.1. Again, I just took 1 point to the right of the rightmost vertical asymptote. So I'm going to plot this point, right? So here's 5. I'm going to go up to 9.1. It's going to be a little high. So this is 5, 6, 7, 8, 9, 10. So I'm just going to try and sketch as best I can. So 9.1 is going to be like here. So what I would do is if you're like sketching this and you like didn't even realize that was going to happen, it has to be a little bit higher. That's 9. And it's not perfect on the scale, guys. I would just draw my vertical asymptote up a little more. It would keep going on forever. Alright, then what I would do is, okay, so now I have 1 point on that curve. I'm just going to kind of draw it best I can. I'm going to kind of go, it's going to kind of go down. That's how the other curve's going to look. So it's going to kind of look something like that. So again, I got my two kind of ends. I got the end here and the end here. It doesn't need to be one in every single region. That's just kind of like, this is what's going to look like. You're going to have this behavior in this area and this behavior in this area. So I found 1 point to the right of my most right vertical asymptote, 1 point to the left of my most left vertical asymptote. And again, it might have been down here. Just you never know. It could be here and here. It just depends on where the point is. Where that 1 point is kind of in the area where it's going to lie. All right. So now finally we have this middle part, right, to figure out kind of the behavior. So I already actually I have my y-intercept here, right, which is the point 0, 9 halves, which was about 4.5, which is like right below my horizontal, right above, excuse me, my horizontal asymptote. We can, for this middle part, we can actually go past the horizontal asymptote sometimes, so it just kind of depends on the problem. But so if you kind of see here, what's happening is, if you kind of see, if I were to just like draw this, it's going to go down here, right? It's going to kind of fall on out. So that's on this side, right? So I have 1 point to the right, all right? But I still want to find 1 point to the left. So what I'm going to do here is I'm going to plug in, let's try my next whole number here. Let's try -1, okay? So again, the reason I'm only finding -1, okay, let me just reiterate. So I have my y-intercept like I had in the last problem, right in the middle, right? Of the two vertical asymptotes. I have my y-intercept in the middle, right? I already have, remember I said I wanted to find a point to the left and a point to the right. I already have a point to the right, 3, 0. I kind of see it's going down this way. So what I need to see is, to the left, is it also going down, kind of like my U, or is it going to curve upwards? That's what we need to figure out. Okay, so I'm going to find f of -1. That is the next whole number to the left of my y-intercept, because I already have a point to the right. So the point to the left, if I plug in -1, I'm going to get the point. It's going to be a fraction. You have to deal with fractions in this, guys, but you just have to deal with really the decimals. I get 32 over 5, which is actually exactly 6.4. So I'm going to get -1, 6.4. So, okay, what does that mean? What's the behavior on the left side of my y-intercept? So I'm going to go -1 to 6.4. So I have 1, 2, 3, 4, 5, 6. So it's a little bit above 6, kind of in the middle there. I'm just kind of sketching it. So that's that point I just plotted. So that's the point. I'm not going to get that confused with the intercept. That is the point, -1 to 6.4, which I just found. So what do I see here? If I look, here it looks like it's starting to go upwards, and here it goes downwards. So it's going to be kind of that little other second curvy graph, kind of like almost like a S this way. So what if I were to draw this curve, or kind of like look at the behavior, it looks like it's going to get really, really close to this asymptote here, go down, it's going to kind of go past here and kind of keep going down that way. So what kind of happens here, it's actually going to cross my horizontal asymptote. It's going to kind of curve up this way and then curve down this way. So it's going to kind of get really close to that vertical asymptote. It's going to go down, 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 and then it's going to get close to that vertical asymptote that way. So instead of an upside down U, it's going to be kind of like a curve up and a curve down. So that's the behavior in the middle. So again, that's why I have to find those 2 points to the left and right of my y-intercept. All right. So those are 3 more graphs. I really hope that helps. Kind of my bonus video. I really hope that's a nice review for tomorrow. I know I didn't go over x-intercept, y-intercept, vertical asymptotes. You guys have the other videos to go over that as well. But hopefully this really helped with the graphing. I really tried to explain it as in-depth as I could and as clearly as I could. Again, hopefully the banging, if you heard downstairs, didn't get in your way or anything like that. Hope you guys have a great day. Study as if this is a quiz, and also you have your assignment to do. So if this helps with the assignment, and you're going to practice graphing today. So again, this is not mandatory. You don't need to watch this. I'll watch it for little hints in the quiz. I'll point that out. But don't feel like you need to watch this whole video if it's a little long and you have a lot of other assignments to do. Again, your only required thing is to do the assignment on graphs. If you understand this stuff, you don't need to, or you can even like skip over some stuff. You just want to look at one of the graphs. All right. Have a great rest of your Wednesday, quiz Thursday, and then we'll go back to lessons on Friday.